Hello students, today we'll start with the gravitation part 3. In this we'll learn inverse square law of gravitation. Let us start with inverse square law. Here when we are talking about inverse square law, I'll teach you the derivation of inverse square law, students. Derivation of inverse square law. Here for that we'll assume, suppose there is a planet which is moving around the sun. Now radius, that means the distance between the center of sun and the planet, is r, and velocity, the speed or velocity of the planet, is v, students. Now we have already studied centripetal force. Whenever any object is performing circular motion, it is getting pulled towards the center continuously, students. The object is continuously pulled towards the center, and this force, centripetal force, is given by F is equal to mv square upon r. We have already studied this formula, centripetal force, in our gravitation part 1 video, students. You can refer from there. So here centripetal force is given by F is equal to mv square upon r, where centripetal force is the force which is acting on a object performing circular motion, and it is always directed towards the center of the circle, students, center of the circular path. Let us continue, students. Now here we are having first formula, F is equal to mv square upon r, students. F is equal to mv square upon r. It is called centripetal force. I'll take it as a equation 1, students. Now students, when a object is performing circular motion, suppose one rotation is done. So here length, distance covered in one rotation, is given by the length of this path of the circular orbit. Length of this circular path is given by the formula 2 pi r, and it is called circumference or perimeter of circle. So in geometry you must have studied this. So here we are having length of the path, total length covered in one rotation, is 2 pi r, which is called circumference of circle or perimeter of circle, students. So you are having formula from geometry. Length of this circular path, that is circumference, is 2 pi r. Now suppose time taken for one revolution, that is called period of revolution, be capital T. So here we are having distance, we are having time. Velocity is given by distance upon time, students. Velocity is given by distance upon time. So here velocity formula, students, here we are having velocity formula. Velocity is equal to distance upon time. Distance is 2 pi r and time is capital T. So we got the second formula, V is equal to 2 pi r upon T, student. So here what I will do, students, first equation we are having from centripetal force, and second equation we are having velocity is equal to 2 pi r upon T. You know why? Because velocity is equal to distance upon time, where distance is 2 pi r, circumference of the circle, and denominator T is the time taken as a capital T. It is assumed as a capital T, students. So we got V is equal to 2 pi r upon T. Now this 2 pi r upon T value I'll put here in equation 1. Instead of V, I'll write 2 pi r upon T, student. So let us write first formula. Here we are having first formula, F is equal to mv square upon r. Now instead of this V, students, we'll put the value of V, 2 pi r. V is equal to 2 pi r upon T. Now let's see what happens to this equation. When I'll check, m is as it is, m will remain as it is, r will remain as it is, students. Now 2 2 is in bracket, that means square will become 4. Pi is again in bracket, square will become pi square. R is in bracket, r square will be r square. T is in bracket, it will become t square. So now we are having formula. Now we are having formula pi 4 pi square m r square upon r t square, students. Here, students, normally what we will do, we'll cancel this r with one r above, but here you will take care, you will not cancel this. Instead of that, you will multiply numerator and denominator both by r, and you will see what are the modifications here. I'll explain you why am I doing this. Here, for when you will see these two equations, next equation, 4 pi m upon t square. See, first 4 pi square m is here, 4 pi square m. This t square is there in denominator, t square. Now r square into r will become r cube, students, and this r into r will become r square, students. So in this way we'll arrange here, we'll arrange the formula by multiplying numerator and denominator by r, students, by multiplying numerator and denominator by r. Now here we have reached till the formula f is equal to 4 pi square m upon r square r cube upon t square. I will repeat again, student. After this step, instead of cancelling r, you will multiply numerator and denominator both by r, and you will arrange the equation like this, students. Here 4 pi square m is as it is, 4 pi square m. Denominator t square is again same as it is, t square. Now r square into r will become r cube, and this r into r will become r square, students. So this is the last step what we got now, and you must have understood how we got this step. Here after this step, when you will check here, we are having r cube upon t square, students, r cube upon t square. Now according to Kepler's third law, students, according to Kepler's third law, we are having t square upon r cube is equal to k. T square upon r cube is equal to k. But when you will compare these two, they are inverted. Here it is r cube in numerator and here r cube is in denominator. So what I will do, students, here Kepler's law, I'll just modify this Kepler's law. K upon nothing is there, that means 1 is there. I'll invert this 2. It will become r cube upon t square is equal to 1 will go up, students, and k will come down. We'll get 1 upon k here. So here in this equation I'll put the value 1 upon k, and our equation will become, see, this part will remain as it is, 4 pi square m upon r square. See, students, this part is same. Instead of second part, we'll get 1 upon k. K will come in denominator, students. K will come in denominator. Now, so this is the final. We got f is equal to, 1 second, students. So here we got f is equal to 4 m pi square upon r square k. In this equation, you will, when you will see, except r square, rest all are constant, students. All are constant except r square. So it can be said that f is inversely proportional to r square. If f is changing, r will change. If r is changing, f will change, students. Because what I said to you, that rest everything is constant, only r square is variable, changing, and f is changing, force is changing, and r square is changing. So as distance changes, force also changes. Rest all are constant, students, and we can say f is inversely proportional to r square. That means if the distance increases, the force of attraction or gravitational force reduces, and if distance decreases, the gravitational force increases. This is called the inverse square law, students. This is only called inverse square law, students. Next, when we'll move ahead, now we are having derivation for gravitational potential energy, students. Gravitational potential energy is the energy stored in an object due to its position above the earth's surface, students. In our ninth standard, we have already studied potential energy is given by mgh, students. Mgh, m is the mass, g is acceleration due to gravity, and h is the height, students. Height here, for height, in all formulas, when you will see previous slides, for height or distance we have used the letter R. So here, even in this formula potential energy mgh, I'll do a small modification, and instead of h I'll use letter R, students. I'll use letter R. I'll just replace h by R, students, and then our formula will become potential energy is given by mg R. R is nothing but displacement. In previous formula it was h, that means height. It was also a displacement only, but it was in vertical direction. So here again the same thing is there, only we are using the letter R, because till now we have used the same letter R for distance between the objects. Now when I'll go for further modification, we have already studied this g value is given by capital G capital M upon R square. Now you will say, why this minus sign? In last formula we are not having minus sign, so here I am having reason for this. Whenever we are moving in upward direction, students, whenever we are moving in upward direction, sorry students, whenever we are moving in upward direction, the velocity reduces, students. Velocity reduces, and whenever velocity is reduces, acceleration is called negative acceleration, and that is the reason why minus sign is over here, students. So this g value I'll put here, and we'll get the formula. M is as it is, students. R is as it is. Instead of g we are having g minus gm upon r square, minus gm upon r square, students. I'll repeat again. First we'll replace h by r and we'll get this formula, students. Now instead of g we'll put the value of g, students. We are having g is equal to minus gm upon r square. Even this derivation, how we got g, we have seen in our last previous video, students, how this g is equal to minus gm upon r square. So I will put this value here, students, instead of g, and we'll get g value minus gm upon r square, and this m and r are as it is, students. M and r are as it is. So here we have reached till here this formula. We are having E, potential energy E, is equal to gmm upon r, sorry, gmmr upon r square. Here r is in numerator and denominator both, students. One r I'll cancel, and what I'll get is equal to E is equal to minus gmm upon r, students. Here when we'll talk about r value is given by r is equal to r plus h. We will say, what is this r plus h now? So I'll explain you, students. Suppose there is earth and there is a object. Now the distance between center of the earth and object, here first part, here this center to the surface of the earth is nothing but radius of the earth, and when you will go above the earth surface, this is height, so it will become r plus h, students. This small r is nothing but capital R plus h, radius of the earth and height from the surface of the earth. So this is your gravitational potential, students. Now we are having gravitational potential is equal to minus g m upon r, students. So gravitational potential energy is given by minus g m upon r, students. Let's move ahead, students. Next topic is escape velocity. Now what is escape velocity? Students, suppose I'll throw any object in upward direction. I will project object in a upward direction. What will happen? After some times the speed will continuously reduce, and after some time speed will become zero, and that object will start falling down. I'll increase the speed while throwing next time. It will go more higher, students. Again I will increase the speed. it will go more higher. I'll keep on increasing the velocity while throwing the object, and the height will keep on increasing. Students, a time will reach when I'll throw the object not by hand. I'll use the machine, I'll use any technology, but I'll apply force, more and more force, and I'll make sure that the velocity increases every time. And a time will come when the object will not fall down, students. It will go out of the Earth's gravitational force, and that minimum velocity which is required, with which a body must be projected so that it may escape from the gravitational field of Earth, is called escape velocity from the Earth, students. I'll repeat, students. Whenever I'm projecting any object in upward direction, if my force is more enough to project the object out of the Earth's gravitational force, the minimum velocity, which is initial velocity required to project that object out of the Earth's gravitational field, is called escape velocity, students. So we are having definition: the minimum velocity with which a body must be projected so that it may escape from the gravitational field of Earth is called escape velocity from the Earth, students. The escape velocity from the Earth is called the second cosmic velocity also, students. Is also called as second cosmic velocity. Let's move ahead, students. Here the picture is shown. Whenever we are throwing any object, two forces are there. One is velocity given by us, and other is gravitational force. And when the velocity is projection, while projecting the object upward, when velocity is more than escape velocity, then object will go out of the Earth's atmosphere. Otherwise it will fall back to the Earth, students. It will fall back to the Earth. Let's move ahead, students. Now expression for escape velocity. Here, students, uh, kinetic energy, we already know kinetic energy is given by half mv square, students. Kinetic energy is given by half mv square, and potential energy formula just now we derived. Potential energy is equal to minus gmm upon r, students. Just now we did the derivation of potential energy, students. Potential energy is equal to minus gmm upon r, students. So here I am having kinetic energy and potential energy. Kinetic energy is half mv square, and potential energy is equal to minus g mm upon r, students. Now here when I'll talk about total energy. Total energy is nothing but sum of kinetic energy plus potential energy. I'll add these two and I'll get total energy, students. Now here, if any object is at infinite distance, both kinetic and potential energies are zero, students. So here, if object is at very much higher uh, height, that is height is infinite, the total energy will be zero, students. And we can write is equal to zero. Total energy is equal to zero. That is written over here, student. Now here what I'll do, students, I'll change the side of the second term. I'll change the side of the second term, that is potential energy. When potential energy will come to the right hand side, when potential energy will come to the right hand side, here potential energy is minus gmm upon r. It will become plus gmm upon r. Plus no need to write, students. Plus no need to write. This minus will become plus and we'll get gmm upon r, students. So now we are having equation half mv square is equal to gmm upon r. What I'll do, students, I'll keep v square here on the left hand side, and rest everything I'll change the side. 2 is in denominator. When you will change the side, it will go in numerator. M is in numerator. When you will change the side, sorry, it will m, no need to change sign, students. M is there on both the sides, so we can cancel m, and m is not there only, students. Now I'll repeat again. Here small m is there on the both sides, so I'll cancel small m, students. I'll cancel small m, and we'll get v velocity square is equal to 2gm upon r, students. Now I'll take the square root and we'll get v escape velocity is equal to under root 2gm upon r. Under root 2gm upon r. Let's move ahead, students. Now we have seen v square is equal to 2gm upon r, students. 2gm upon r. Also we have formula g is equal to gm upon r square. Gm upon r square. From this formula we have already studied and we have used this in many derivations. Here this g formula, I'll change the side of r square, students. I'll repeat, students. We have reached till in last slide we got this formula v square is equal to 2gm upon r. Now g is equal to gm upon r square is known to us, students. We have already studied the derivation of g, acceleration due to gravity, in second last video, students. That is second video, gravitation part 2. Now in part 3 we are using this g, gravity, acceleration due to gravity. What I'll do, students, I'll change the side of r square. I'll change the side of r square and we'll get gm is equal to gr square. This value will put here, students. This value will put here in our previous formula. V square is equal to gm upon r. Instead of gm we'll get gr square, students. So we will have formula 2gr square upon r. Here r is in their numerator and denominator both will cancel and we'll get v square is equal to 2gr. 2gr. We'll take square root, students. We'll take square root. It will become under root 2gr. Let's put the value of g and r. We got v is equal to under root 2gr, students. We'll put the value of g 9.8 and we'll put the radius of earth is equal to 6.4 into 10 raised to 6. When we'll put the value here, students, 2 is as it is. Students, here it should be under root sign should be there. It may be printing mistake or something. That's why root sign is not there, but it should be there, students. 2 value is there, g value is 9.8 and r value is 6.4 into 10 raised to 6. Now when we'll solve, we'll get is equal to 11.2 kilometer per second, students. Value of escape velocity is different on different planets, students. On earth it is 11.2 kilometer per second, students. So this is about the escape velocity, students. In our next lecture, students, will study the matter and materials and will continue with the force and weight concept, and afterwards we'll solve few sums and then we'll finish the chapter in our next video, students. For today I'll say thank you to you all for watching my video and attending this lecture, students. Thank you, students. Thank you very much.